we are back. Today I'm going to be talking about inorganic and organic compounds. Once again, this is just kind of a little scraping of information. And soon we'll be starting to dig a little bit deeper into everything. I want to say, if it's not the next lecture, the next one. And then continuing on through the program. Okay, so I'll make sure I talk a little louder. This is actually, I think this said day 4, but we are actually on day 5. Yes, we're on day 5, so just don't worry about the days. These were PowerPoints from previous times. Okay, so organic, when we think about organic, it's a little different when we're talking about organic compounds than for what the term organic that we usually hear every day. When we think of like organic groceries, we think of things that are free of pesticides or any type of, like more natural, I guess, basically. I was going to say non-GMO, but that might even be a different category within itself. But organic, when we're talking in chemistry, we look at it as elements. They have to have atoms that have carbon and hydrogen. Okay, so in chemistry, organic molecules come from life and must contain an atom of the elements carbon and hydrogen. Organic compounds can be very complex, and there are many more organic compounds than there are inorganic. Okay, just so you know, a little background information. All right, and I'll be talking a little bit more about these, probably more than you need to know. Don't worry about, really knowing what all these chemicals are. I just found them interesting. I always kind of want to know a little bit more about it. So when we're looking at examples of organic compounds, we can look at solids, liquids, volatile substances, and gases. And these are different examples of, okay, so diamond, you're familiar with that. Coal, graphite, acids like acetic acid. Okay, acetic acid is generally like vinegar when frozen. Sugars and fats. And then when we look at the different liquids, we look at benzene. And benzene is actually found in crude oil and is a major part of gasoline. It is actually used to make plastics, resins, and synthetic fibers. Benzene is actually produced naturally by volcanoes and forest fires. So again, just a little trivia there. So pyridine is structurally related to benzene and is used as a catalyst. So remember, a catalyst is something that speeds up a chemical reaction. Ethanol, we should be familiar with ethanol. It's like alcohol, a form of alcohol. Acetylene is used as a fuel when liquefied, compressed, heated, or mixed with air, and then it becomes highly explosive. Okay. Volatile substances include naphthalene, and that's actually used in mothballs. Okay, and gases then would include methane and then acetylene. Okay, and that's what we were talking about, how if that was compressed or heated with air, it becomes explosive. All right, so just a little tidbit of information there. Organic molecules in our body. Now these 4 you definitely want to know. Okay, and I know you talk about these also, I believe, in A&P. And so some of my resources, I actually referenced our A&P, your A&P book that you use for Nicole's class for some of this information. So the 4 types of organic molecules are carbohydrates, lipids, proteins, and nucleic acids. So carbohydrates, these organic molecules contain atoms of carbon, hydrogen, and oxygen. And the ratio then is 1 carbon to 2 hydrogens to 1 oxygen. Okay, so that's the ratio, 1-to-1 ratio. And the simplest form of a carbohydrate is called a monosaccharide. Okay, so the monosaccharides, they're simple sugars. They are basically the building blocks of carbohydrates. Okay, again, a lot of terminology here, and part of your homework for this after this lecture is a crossword puzzle that's just a good review of all the terminology that we've covered so far, and it's a good thing to, I think it's hard to really get them wrong. If you're not sure, email me, but just given the fact that it's in a crossword puzzle format and I give you a word bank, you should be able to figure out where they all go. Okay, and so that's a good review tool for your exam 1, which is on Friday, May 8th. Alright, so again, monosaccharides are the simplest form of a carbohydrate in the building blocks of carbohydrates. A glucose is an example of a monosaccharide. Okay, carbohydrates then are their main energy source for cells. Glucose is converted to glycogen for storage. And glucose is found in blood, and your glycogen then is found in your muscles and your liver. Okay, so on the next page here you kind of have a little picture of, kind of getting an idea where that glucose is that monosaccharide. That's that one simple sugar. Okay, and this is page 30. This might not quite match with your, because this was the older edition in your textbook, but it's definitely in chapter 2 in your A&P book. Let me look really quick. No, it's really not on page 30. Let me see if I can find it. Oh, it would be on page 40. Okay, so on page 40 of your textbook. So I'm going to make a little note. Page 40 in the new textbook. Okay, I also have the old edition. All right. So, and then you can see the two of them then would be considered a disaccharide, meaning 2, and then polysaccharide would be a chain of them. Okay. To form a polysaccharide like glycogen. So again, this came out of chapter 2, A&P. All right, so lipids also contain atoms of the same element as those that are in carbohydrates, the carbon, hydrogen, and oxygen, though they're not in the same ratio. And the building blocks of lipids are fatty acids and glycerol. So examples of fatty acids are fats, steroids, and phospholipids. They are mainly found in adipose tissue, hormones found in the blood, and cell membranes. Their function is stored energy. They help regulate body temperature, transport other molecules, aid in chemical reactions. They fight foreign invaders and allow muscles to contract and hold cells together. Okay, so yeah, I was going to say something, but that's on the next slide. Sorry. Okay, proteins, they also contain nitrogen along with the carbon, hydrogen, and oxygen. And their building blocks are amino acids. So these terms, fatty acids, amino acids, these are things that you want to know. And there's 20 different amino acids. So proteins function in many different ways according to their shape, and their shape is determined by the order of the protein's amino acids. So you kind of think about them like a key. So each key, basically, like on your key chain or your key ring, has a different purpose. Even though your keys are basically made of the same metal, they do not open the same locks. So a tiny variation in the shape can make a huge difference on whether the key works or not. And that's how we kind of look at proteins, okay? And how the amino acids, the proteins' amino acids, by the shape of them. So they can be found pretty much everywhere. Your skin, your blood, your muscles, your cell membranes. And their functions include they give you strength, they help regulate the body, transport other molecules. You know what, I think I just read the wrong thing before, now that I'm saying that. Huh, I did, I'm sorry. So reread your function for the other one on lipids. I think I looked, my eyes went up and then I looked at the wrong part of my paper here. So back to lipids, they are found in adipose tissue, hormones found in blood, and cell membranes. Their function is in stored energy. They regulate the body hormones and give structure to cells and help regulate what goes in and out of their cells. So I'll reread the previous slide with lipids, because I think I just read the stuff for protein for lipids. Oh my gosh, I'm losing it. Okay, so back to proteins then. As you can see, their function is things I already said. Fight foreign invaders, allow for muscles to contract and hold cells. Sorry about that, my eyes got crossed. Alright, moving on. New piece of paper. Nucleic acid. So these organic molecules are composed of carbon, hydrogen, oxygen, nitrogen, and phosphorus. Okay, their building blocks are nucleotides. And RNA and DNA are actually examples of nucleic acids. Okay. The nucleotides in DNA are guanine, cytosine, adenine, I'm terrible at pronouncing, thymine, and RNA is uracil, is substituted for the thymine. So your DNA contains basically all the genetic information that makes you up. It is written in its own language called genetic code. Okay, so genetic code is definitely a word that you want to know. Your DNA has approximately 3 billion base pairs of nucleotides to record all the information and directions onto how your body actually works. Okay, and the gene is the amount of DNA that must be read to give you the directions to make one specific protein. If you look at the chart on page 40, I believe, of course it might be 50 now, it talks about So if you look again at the chart on page 40 in your textbook under table 2.2, it kind of breaks down like all and kind of categorizes all these organic molecules, your carbohydrate, lipid, protein, and nucleic acid. So it's kind of nice because it's all kind of compact there. So that's page 40, chapter 2 of A&P. All right, biomolecules. These are molecules that occur naturally in living organisms. These include your macromolecules. So remember, these are macro, not micro. Macromolecules like proteins, carbohydrates, lipids, and nucleic acids. Okay. Also included are small molecules like primary and secondary metabolites and natural products. So inorganic compounds are then compounds that don't contain carbon bonded to hydrogen. That's what makes them different. Many inorganic compounds do contain hydrogen atoms, such as water, H2O, hydrochloric acid, HL, that are produced by your stomach. CO2 is actually another one, your carbon dioxide. There are 3 groups of inorganic compounds that are essential to life. These are water, salts, and acids and bases. So we're going to talk just a little bit about water here, and then we'll be talking a lot more about salts, acids, and bases next week. So in fact, we may even start acids and bases, I believe, on Friday. Yes. All right, so water is the most abundant inorganic substance in the human body. Our body consists of about 70% water weight. This water is found both within our cells and between the cells that help make up our tissues and organs. Water acts as a lubricant and a cushion. It helps maintain body temperature. It helps doing this by absorbing heat. It's considered the universal solvent. Life cannot exist without it. And water participates in chemical reactions. Water can be referred to as hydrophilic, meaning it loves water and dissolves easily in water, like the chemical reaction, or it could be hydrophobic, meaning it does not dissolve readily in water, so it fears water. Alright, kind of going to go back a little bit here, talking about balanced equations again. Okay, so the sum of all chemical reactions that take place in the human body is called metabolism. You must bring these molecules together for them to react to one another. And we can do things happen for them to react more quickly. Okay, so what are some of the things that you can think of that make chemical reactions happen more quickly? Well, if you have more of them, increase the concentration of the reactants, that's going to make it happen more quickly. If you increase the speed of the reactions, or the reactants, sorry, the heat then speeds up the motion of the molecules. Okay, so we should know that from basic science. And using a catalyst. Okay, so a catalyst is any molecule that speeds up a reaction without being chemically involved. Okay, so it doesn't really change the reaction. It doesn't become chemically involved. So enzymes are often act as catalysts. So they facilitate the reaction without actually becoming involved. They don't break down into the reaction. Okay, so catalysts often are enzymes. Okay, so talking again about cellular respiration. So some reactions that require that energy be added for them to occur. Other reactions release energy. Okay, remember that cellular respiration releases energy. So these reactions release energy, help in the chemical bonds between the atoms and the molecules, such as cellular respiration. So cellular respiration is one of the most important chemical reactions in the body. That is a test question. I know that. You have to pick. And what is one of the most important chemical reactions in the body? Cellular respiration is your answer. I also posted a Quizlet too to help you study. So here is the cellular respiration reaction. It's not quite balanced yet, so just kind of keep that in mind. We're going to show you that on the next slide. So we have the reactant side on the left, and on the right side we have the product side. Okay, so as we're looking at this, this is glucose plus oxygen, okay, is on the left side, yields, okay, so your arrow is kind of basically saying yields, carbon dioxide and water. And right now, as we look at this, we have 6 carbons on the reactant side and only 1 on the product side. We have 12 hydrogens on the reactant side and only 2 on the product side. And oxygens, we have 8 on the reactant side, and on the product side we have 3. Okay, so to balance this equation, numbers then are placed in front of the molecules. So as we see here, we went ahead and we changed it up a bit, and we added some numbers in front. So now, when we look at this, we should have 6 carbons on each side, 12 hydrogens on each side, and 18 oxygens. Okay, and you can actually add energy to this, to the bottom equation, the one that's balanced, plus energy. Okay, so the reason our cells perform respiration is to release the energy within the bonds of the glucose molecule. These cells cannot use the energy contained in the chemical bonds of glucose until this energy has been released through cellular respiration and converted to a usable form. And the usable form is, does anybody remember? I'm wondering, ATP. Okay, so ATP is our usable form. Okay, that's basically our currency. So like when you get paid with a check, the check is really not a usable form of money. the check needs to be converted to cash so that you can spend it. Of course, now anymore everything's with a card, but so I guess that would be your usable form. So the energy released from the glucose molecule in cellular respiration must be converted again to this usable form. The energy contained in the chemical bonds has to be converted, and this involves another chemical reaction. So we have energy again plus ADP plus P, which is a phosphorus, so it's a diphosphate, I believe. I gotta look it up. Yeah, yes. And then plus P equals ATP. Yes, because this is the third phosphate. ATP contains the usable form of the energy for the cell. This energy is released from a glucose molecule's chemical bonds via cellular respiration, and then it helps to form a chemical bond then between the ADP and that third phosphate. Cells can easily break the bond between the third phosphate and the adenosine, releasing the energy as needed. Okay, so yes, it's adenosine. Adenosine is so confusing because there's a medication that's similar to this phosphate. So we have diphosphate. So adenosine diphosphate. So we have energy plus adenosine diphosphate. As you can see, there's just two phosphates. Then you add another phosphate, and that gives us the ATP. And this is actually in page 46 in your textbook, in your A&P textbook. Okay, I did include those videos again for balancing equations. They're also on the balancing equation lecture, but I stumbled upon these when I was going through this lecture, and I just went ahead and left them there in case you need to revisit those. And these are my references. This course is lumenlearning.com, and Anatomy and Physiology was a helpful website too. Okay, we'll talk to you next time. Thank you.